This video is going to cover the T.1.G notes on circular trig. Okay, so we're going to look at the circular definitions of trig functions. In geometry, in last class you did right triangle trig, and now we're going to look at circular definitions. Okay, so if I were to pick a point on this circle, so I'm just going to pick this one right here. This is the point 1, 2, 3, 4, 1, 2, 3, 4, 3. Okay. I pick a point on the circle, and I'm going to draw an angle so that one of my rays goes through that point. Alright, so there's an angle in standard position, okay, and it goes through the circle. If I want to find the trig function, so sine, cosine, tangent, any of them, for this angle, what I would do is draw my reference triangle down to the x-axis just like we've done before. Okay, and now I need the sides of the triangle to be able to figure out the value for the trig functions. Alright, this line I drew along the x-axis out to 4 because this point is 4, 3. So this line has this side has a length of 4. And then this side we know has to have a length of 3 because that's the y value of this coordinate that I picked. So I have 4 and 3. Okay. And then I could find the length of the hypotenuse. I just have to use the Pythagorean theorem, but I also know that 3, 4, 5 is a Pythagorean triple, if you remember those from geometry, so I know that my hypotenuse has to have a length of 5. So now I have the lengths of all three sides of the triangle, and I could find the value of any of the trig functions. But what we would notice is we're going to start to see a pattern emerge that no matter where if I pick a point anywhere on this circle, then the side of the triangle that is on the x-axis is always going to be equal to the x-coordinate of the point that's on the circle. Alright, and then this side that we draw down to the x-axis is always going to be equal to the y-coordinate of the point. Okay, and then this line, the hypotenuse that we drew, is also a radius of the circle. Alright, because it goes from the center out to the edge. So it is a radius of the circle. And so what we're going to do is use this pattern, this x, y, r, to come up with another set of definitions for our trig functions. So previously we've dealt with right triangles, and when we defined the trig functions, we said this side was the opposite side, this side was the adjacent side, and this side was the hypotenuse. So we should know the triangular definitions, because these are from geometry, of all of the trig functions. So sine, remember, is opposite over hypotenuse. Cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Those were our SOHCAHTOA. Alright, then we found out the inverse ones. So cosecant is the opposite of sine, so it would be hypotenuse over opposite. Secant was the opposite of cosine, so it would be hypotenuse over adjacent. And then cotangent was the opposite of tangent, so it's adjacent over opposite. Okay, so this is all review, all of the triangular definitions, looking at a triangle, defining the sides, and then what the trig functions are equal to. We're going to also have a circular definition. So if I drew a circle, okay, and just like we did on the last slide, I pick a point, alright, and I'm going to draw a triangle, and now I'm finding the trig functions for this one. Remember we said that this side is always going to be equal to the y-coordinate. This side is always going to be equal to the x-coordinate of this point, and this side is a radius of a circle. So on a triangle, sine is opposite over hypotenuse, but on a circle, sine is y over the radius. Alright. In a triangle, cosine is adjacent over hypotenuse, but on a circle, cosine would be x over the radius. Alright. Tangent would be y over x. Then we have the reciprocal, so cosecant would be the opposite of sine, radius over y. Secant would be the opposite of cosine, so radius over x. And then cotangent would be the opposite of tangent, so x over y. Alright, so circular definition, now we're dealing with x, y, and then the radius instead of opposite, adjacent, and hypotenuse. Why do we do this? Alright, we have the triangle definitions already. Why do we need another set that seems to say the same thing? Well, when we are doing right triangles, I can only draw a right triangle with positive acute angles. In other words, if I draw an angle and it has a measure of 50 degrees, I can make a right triangle out of that, right? But if I draw an angle that has a measure of 110 degrees, I can't make a right triangle because 110 plus 90 is 200. That's already more than 180, and the angles in a triangle can only add up to 180. So we need the circular definitions so that we can do some other angles besides positive acute angles. We need the circular definition so we can get the rest of the circle. And these are some of the many things that we can do once we have the circular definitions. We can develop something called the unit circle. All right, we can verify trig identities. We can graph trig functions. We can actually graph sine and cosine and tangent and all kinds of other things. And this is the stuff that we're going to spend the rest of the semester doing once we have those circular definitions. Okay, so we're developing the basics so that you can get into a lot more of trig than you ever thought was possible just from geometry. All right, so for right now, here's the basics. I'm going to give you an angle. I'm going to give you a point on the terminal side of the angle. So -9 square root of 19. Okay, and what you're going to do is draw the reference triangle. So I'm going to draw a line straight down to the x-axis. Okay, and then remember, the side that's on the x-axis has to have the same length as the x-coordinate of the point. This side would be the y-coordinate. Okay, and now you have two sides of a triangle. You can figure out the third side, and this asks you for the secant. Okay, so remember secant, if we get our circular definition, would be r over x. Okay, and right now we have the x, but we need the radius. All right, find the radius. I'm going to use Pythagorean theorem. So the square root of 19 squared plus -9 squared equals r squared, because r is what we're trying to find. So do this, square these and add them together, we get 100 equals r squared, so r has to be equal to 10. Alright, so I know this has a length of 10. Secant is radius over x, so 10 over -9. Alright, that can't be simplified at all, so that is my secant for this angle. I will do another one. Again, you're always going to draw a reference triangle down to the x-axis. Okay, this side has to have the length of the x-coordinate. This side has to have the length of the y-coordinate. They want cotangent. Alright, so remember, circular definition for cotangent would be x over y. So in this case, I don't need the radius because all they want is the cotangent. So x is -16. Y is 11. Those can't be simplified. That's my answer. Okay, so we're going to do a lot more throughout the semester with these circular definitions, but right now we're just practicing the basics.